begins as three gentle streams in the lush mountains of eastern Kentucky, which then join to form a wider river flowing west, the Cumberland. Past Cumberland Falls, famous for its spectacular views of moonbows, the river plunges southward into Tennessee. After flowing through Nashville, the river continues west and then rolls northward back into Kentucky, ultimately merging with the Ohio River. Serving as a trade route to the Ohio and Mississippi rivers, the Cumberland helped establish Nashville as a riverboat port and nurtured it into the thriving city it is today. Yet any city that owes its existence to the beneficent proximity of a river knows that it is also subject to its occasional cruel vagaries. In May of 2010, powerful thunderstorms dumped over 13 inches of rain on the region in 2 days. Like other bodies of water, the Cumberland swelled with the rainwater, cresting at 12 feet above flood stage, and inundated Nashville and surrounding neighborhoods, causing unimaginable destruction. The Gaylord Opryland Hotel, located near the river, suffered tremendous damage. Floodwaters reached as high as 10 feet in some areas of the atriums and other public spaces. The nearby Grand Ole Opry was not spared either, with 4 feet of floodwaters covering its iconic stage. But the people of Gaylord, like all other Nashville residents, were determined they would recover, that they would do whatever it took to come back stronger than ever. And come back they did. On November 15, 2010, just 195 days after the flood, after unceasing efforts by hundreds of construction workers who would put in 16-hour days, the Gaylord Opryland reopened. True to their promise, hotel management had made the Gaylord better, more impressive, more striking, more splendid than it had been before the flood. Determination to recover from adversity is something the powder metallurgy industry can readily identify with. During 5 years of declining demand for its output, tied to the dismal fortunes of all manufacturing and raw materials industries, PM was determined to survive the hardships, to treat the difficult circumstances of the recession as opportunities, and to rebound stronger than ever. How the industry has rebounded, and it has done it by relying on its historical strengths of design engineering advantages, material versatility, economic worthiness, and sustainability credentials. Excellence in design has shown the way in the remarkable recovery PM has experienced, in helping the industry hold on to its traditional markets, build on more recently earned market opportunities, and stake out footholds in novel applications. There's no better time to celebrate the role design plays in the industry's prosperity than right now, as we present the winners in the 2012 Design Excellence Awards competition, sponsored by MPIF. 10 grand prizes and 10 awards of distinction have been given this year. We'll begin with the awards of distinction. Solid Micron Technologies Private Limited, Singapore, has won an award of distinction in the automotive engine category for a valve seat made for Magneti Marelli SPA powertrain in Italy. Fabricated via metal injection molding, the stainless steel component is part of a direct fuel injector used in an automotive engine assembly. The presence of multiple angled slot and top holes of small diameter, coupled with the thin wall section, required precise tool design and fabrication and injection parameters. As a near-net shape requiring minor machining processes, the MIM part yielded a 30 to 40% cost savings and contributed to sustainability by reducing material consumption by about 40%. Another award of distinction in the automotive engine category has been given to a soft magnetic composite solenoid core made by Burgess Norton Manufacturing Company for its customer, Cummins Incorporated. It's used in a high-pressure fuel injector in high-performance, mid-range, and heavy-duty diesel engines, helping increase fuel efficiency and reduce emissions. The part is conventionally pressed with 3 lower punches, a core rod, and 1 upper punch in a heated die with compaction pressures in excess of 60 psi. Formed from a high compressibility, inorganically insulated iron powder, the component is pressed to net shape, with fully automated deburring being the only secondary. This iron-copper-steel synchronizer hub, made by the Asturias, Spain plant of the PMG Group, has won an award of distinction in the automotive transmission category. Made for Aichi Machine Industry Company Limited, the part is used in first and reverse gears in a double-clutch transmission, transferring torque from shaft to gear through a sliding sleeve. Due to the high torque the hub has to withstand, the strut area was reinforced by the addition of a step to increase its thickness. 5 levels on each side are necessary to form this very complex shape. This PM-designed part achieved savings of 25% over the formerly broached version. ACL Bearing Company and its customer, Futurus Automotive Interiors Australia Proprietary Limited, have received an award of distinction in the automotive chassis category for this iron-copper-steel spacer tube. The part, a new component in a steering application, is used to provide positive steering column reach adjustment as well as support to the tilt adjustment components. The part must also provide energy absorption and impact resistance to meet collision requirements. As a center brazed assembly of 2 compacted halves, each with 1 upper and 3 lower levels, the spacer tube pushes the boundaries of geometric possibilities. Porite Taiwan Company Limited has won the award of distinction in the lawn and garden off-highway category for its diffusion alloyed steel gear, one of 5 PM gears in a gear output box for a tiller transmission made by Pubert SAS, France. Achieving a more uniform density distribution in a rather long part, 62 millimeters in this case, always a challenge for PM, required sophisticated powder movement technology. The complex part geometry is formed using 2 upper and 3 lower punches on a CNC-controlled multi-platen 500-ton hydraulic press. The component achieved a cost saving of over 50% versus a forged and machined version. This iron-copper-steel rack, made by Capstan and used in an industrial washing machine application, has earned an award of distinction in the hardware appliances category. The rack is a 7-level part requiring 6 punches, as well as special robotic automation to remove it, flip it 180 degrees, and place it on a special conveyor. It has a critical precision requirement in the perpendicularity of the U-slot to the opposing locating surface. That surface has a critical flatness requirement that is maintained through specially engineered center fixturing. The PM rack replaced a die-cast alternative at a 38% cost reduction and with enhanced precision. 6 17 4pH stainless steel parts formed via the MIM process by Megamet Solid Metals Incorporated and used in a cable tie tool made by Hellerman Titan have received an award of distinction in the hand tools recreation category. The parts, nosepiece, pawl gripper, short link, cutoff cam, insertable rack, and pinion are all produced to net shape, with only 4 parts requiring minor secondary operations. By shifting from casting, stamping, and machining operations to MIM, the customer was able to incorporate cosmetic improvements, reduce part count and assembly steps, provide a lighter weight assembly, increase durability and improve performance, all while meeting their price goals. A bronze solvent filter made by Capstan California for Sperry Product Innovation Incorporated has won an award of distinction in the Industrial Motors, Controls and Hydraulics category. The part is used at the bottom of a solvent pumping system to filter out impurities in order to prevent tubes from clogging. Made via the gravity sintering process, the net-shaped part uses a design that enables various steps to be molded in. This feature enlarges the surface area and increases the flow and dirt-holding capacity. The only secondary operation is hand deburring one outside edge by sandpaper belt. These 4 stainless steel parts made by Advanced Materials Technologies Private Limited, Singapore, have won another award of distinction in the Industrial Motors, Controls and Hydraulics category. Made via metal injection molding, the parts, 2 catches and 2 support tabs, are used in the print module of an industrial printer. Acting as datums, the catches serve as a paper guide. The tabs support and align the printhead. Switching to MIM provided superior surface finishing, corrosion resistance, and strength as compared to the previous process of zinc casting plus machining, and achieved a cost saving of around 40% at the same time. This 17 4pH stainless steel lever made through the MIM process by Smith Metal Products for Methode Electronics Incorporated has won an award of distinction in the Electrical Electronic Components category. The part functions as a latch ejector mechanism on an RJ45 hot pluggable transceiver module for high-speed gigabit Ethernet, designed for easier insertion and removal. The tool requires multiple slide actions to achieve the target geometry and the position of the goalpost arms critical for product performance. Cost savings, higher quality, and improved supply chain performance enabled this part to be recaptured from the previous Chinese supplier. There you have them, ladies and gentlemen, the winners of Awards of Distinction in the 2012 PM Design Excellence Awards competition. Please join with us in saluting them as we invite them to come up to the stage to receive their awards.